In the last lesson, we learned about the break statement, our emergency stop button. It lets you exit a loop immediately, no matter what the loop condition says. That's perfect if a critical error occurs. But what if the error is minor? Imagine you are looping through a list of 100 students to calculate their grades. On student number 50, you find that their score data is corrupted, a negative number, for example. If you use break, you stop the calculation for the remaining 50 students. That's inefficient. You don't want to stop the whole loop. You just want to say, skip this one bad student and move immediately to student number 51. We need a way to skip the rest of the code in the current iteration and immediately jump to the next one. Welcome to lesson 3.08. Today, we are learning the second loop control keyword, the continue statement. While break terminates the entire loop, the continue keyword only terminates the current iteration of the loop. When the program encounters continue, it immediately skips all remaining code in the loop block. For a for loop, it jumps straight to the update section, I++. For a while or do-while loop, it jumps straight to the condition check. This lesson will focus on, first, using continue to skip invalid data filtering. Second, understanding the execution flow of continue in different loop types. First, using continue to skip invalid data. The main use of continue is to filter out unwanted or invalid data and save processing time by avoiding unnecessary operations. Let's use a for loop to print all numbers from 1 to 10, but we want to skip the number 5. The loop runs for I equals 1, 2, 3, 4. Everything is normal. When I hits 5, the if I is equal to 5 condition is true. The continue statement executes. The program immediately skips the printf processing item, %d new line, I line below it. It jumps straight to the update section, I++, setting I to 6. The loop resumes normally for I equals 6, 7, 8, 9, 10. The output clearly shows that processing item 5 is missing. Second, the trap placement in while and do-while loops. The placement of continue inside a while or do-while loop is extremely dangerous if you forget one thing, the update step. Remember that while and do-while loops require you to manually put the counter update, I++, inside the loop block. I is 1, 2, prints normally. I hits 3. Continue executes. The program skips the I++ line. It jumps back to the while, I is less than or equal to 5, condition check. Since I is still 3, the condition is true. It runs the loop again, hits continue again, and skips the I++ again. The value of I is permanently stuck at 3. This is an infinite loop. The rule. If you use continue in a while or do-while loop, you must ensure that the variable controlling the loop's condition is updated before the continue statement executes. A safer design for the while loop would require restructuring the logic or wrapping the code that might be skipped in an if block, ensuring I++ runs every time. Third, summary. Break versus continue. Break, function. Exit the loop entirely. Effect. Stops the entire process and moves to the code after the loop. Analogy. Hitting the emergency stop button. Continue, function. Skip the current iteration. Effect. Skips the remaining code in the loop block and immediately starts the next iteration. Analogy. Pressing the skip button on a video playlist. You now have the tools to control the flow of your program. Decisions. If-else-if switch case. Repetition. For while do-while. Control. Break. Continue. With these things, you can start solving many problems. The next step is the most important part of becoming a programmer. Practice. Click on the next video to receive your final set of challenges for this section. Lesson 3.09. Exercises to practice programming thinking skills. No answers. You should try them yourself before moving to the solutions.